So today we have got Will Smith and Kevin Whitefield joining us to ask some questions. Let's speak to Will first of all. Hi there, Will. How's it going? Can you hear me okay? Doing its connecty.
Hello.
Aha.
Hi, Joe.
How's it going?
Yeah, good. Yourself?
Yes, good, thanks, mate. Just navigating the intricacies of waiting rooms and...
Yeah.
How's things?
Yeah, good. Yeah, not too bad.
Cool,
Is
man.
it just us on today?
Sorry, we've got Kevin, who is waiting in the wings, who sent me some questions about his very cool rammed earth project. But if we speak to you first of all, and then you can linger while we talk to Kevin.
Yeah, that'd be great.
Brilliant stuff. Hi, Kevin. I'm just going to speak to Will, and then we'll bring you on if that's all right. Perfect. Great. Will, tell me, what's your project?
So, haven't got a particular project at the moment, but we're going to have something in the future. So, did the self-build primer with you.
Cool.
With a view to prep, and it's really helped with kind of, well, obviously you know the content. It's helped with all of that. So, understanding basically from our side, planning and building control and
brilliant
the intricacies of that.
Yes. Good stuff. And it was
so
has it been useful?
Yeah. Well, there's a fair bit of stuff that hadn't considered before. So, and a lot of the spreadsheets and the costings are really going to help with the planning and everything. So, yeah.
Yeah. Good. Well, I'm glad to hear it. Yeah. I mean, one of the main reasons that we kind of put that together was just because, you know, you just don't know what you don't know. And it's such a kind of mental kind of journey that kind of forewarned is definitely forearmed. And some of it can be a bit intimidating, but, you know, I'd rather get that out of the way at the beginning and then have plain sailing through the project.
Exactly.
Yeah.
Right. Thanks.
Nice, pleasure. So have you got ideas of what you want your project to be?
Yes. So one of the participants a few weeks ago was talking about a subterranean greenhouse, which we've got quite a sloping site. We were also thinking of starting with something like that. Since then, we've managed to inherit a normal aluminium greenhouse, so we've gone with that to start with. But it's a large site. We've got 2 acres here with quite a smooth gradient across the whole site. Cool. So eventually we're thinking of building a alternative built holiday cottage probably on the meadow across the way.
Nice.
So built into the slope itself, like dig it out and terrace it a bit.
Yeah, brilliant. Yeah, earth sheltering's great. You know, any decision has its own compromises or complications. Earth sheltering specifically is obviously the kind of the age-old kind of damp issues that you have with kind of building into a bank. But all that usually means is that you have kind of some kind of sacrificial cavity between you and it to work with, and it's, you know, it's a problem that's been solved over and over again. So it's by no means difficult to solve. But yeah, all of the benefits of earth shelter is fantastic. Yeah, really. And as a holiday let kind of thing, that just, you know, it's not something that people are used to as well. So
exactly.
Nice.
So yeah.
Cool. Whereabouts are you?
Herefordshire, so between Ledbury and Hereford.
Oh, cool. Yeah, nice. We've got our yard at the moment is down in the Forest of Dean.
Okay.
So it's not too far away from you guys.
Yeah, indeed.
Yeah, cool. Well, that sounds exciting. What's your timescale, or are you just kind of rolling with it?
Yeah, exactly. So we haven't got any money for a build at the moment, so it's saving up for a couple of years, planning and coming up with some ideas really.
Nice.
So timescale indefinite.
Yeah, when it happens.
Yeah, exactly.
Yeah, definitely. Yeah. Have you got aspirations to do other things with the site then? Is it, 'cause 2 acres is a reasonable amount? Are you going for like a self-sufficiency thing or?
Yeah, we've got quite a market garden going on the one side at the moment. So that's seeing us, and we're selling bits as well. And
Cool.
yeah, with the other side, in the meantime, potentially putting a little campsite up. Just this year seems to be the year to do that.
Yeah, definitely. Yeah. Get on the network. Well, everybody's still holidaying in the UK
That's it.
before they could escape.
Yeah.
Yeah. Nice. Well, that sounds great. I love projects like that that are right at the beginning when they're so kind of full of promise. When there's, it can be a bit intimidating because it's like, well, we could do anything. How do you choose?
Exactly. We've got literally a big blank
Yeah,
canvas.
it was really difficult. I'm glad I haven't had, to a certain extent. We're actually just buying somewhere at the moment, which has got a little tiny bit. It's just a house with a bit of land, and I've not let myself kind of go into that dream space yet.
Yeah.
Because it's just like, where do you stop? I've got to try to be practical and pragmatic about it and make decisions. It's really hard.
And if there's no rush, then that helps.
Yeah, exactly. This is it. I mean, luckily, I've got lots of other people's projects that I can vicariously live through, and slowly but surely just kind of pick all the best bits. And going, oh, I like that idea. I'm going to steal
Yeah.
that.
Get involved.
Yeah. One day, I'll get to do some of it myself. That is good.
So it's about upskilling from our side at the moment, really.
Yeah.
And yeah, learning.
Yeah. Well, we are literally just starting our kind of training thing at the moment, which we are aiming more at people who want to work in the industry, because there's not enough people and we need more people who can build with these materials. So we're starting to run courses, but they're not exclusively for people who want to be contractors. There may well be some some opportunities and some overlap for people who want to develop skills, and that's going to be an ongoing thing. So we start our first one the week after next, and then from now on we will have projects always with those kind of things going on.
Fantastic. Well, I've been having a chat to Arif and potentially coming along on towards the end for the lime and clay plastering.
Brilliant. Yeah, that'd be great. Yeah, they should be really good. I'm really looking forward to it. I've just been we've been doing a load of inventory and kind of checking what tools that we've got, and then it's kind of last minute get stuff serviced, and then I've had the joy of spending a little bit of money on some new bits and pieces of tools today, which always makes me happy. So it's really nice to kind of get out of the kind of the office mentality back into the kind of practical delivery.
Yeah, I bet.
Especially after 18 months of nothing.
Exactly.
Yeah, we're looking forward to it. It's going to be good. Messing with some straw and some mud again.
Yay.
Yeah, it should be all good. Cool. So you said you haven't really got any kind of specific questions. You're just kind of absorbing.
Yeah, exactly. And I found it really useful looking at the previous Q&As as well, and some of the people's questions are really useful.
Good. Well, that's why we're doing it. Cool. Great. Well, if you are happy, I'm going to mute you and chat to Kevin, who's got some questions about his project, which I think is a subterranean greenhouse that you were looking at before.
Yeah.
He's got a really interesting project. So.
Fantastic.
Great stuff. Do send me a message in the chat or something if you want to ask a question or anything, and hang around. That'll be cool.
Yeah, will do. Cheers, Joe.
Nice one, mate. Hey, Kevin.
Hello. Good to see you again.
Yes. All good. How are you doing? Getting lost in the detail.
I'm keeping busy. A bit frustrated how long everything takes.
Yeah, tell me about it.
The more detail you try and get in, the longer it takes.
Yeah, I was kind of expecting things to slowly kind of get easier and more like normal as people pretended to go back to normal, but it's not changed. Everything's just taking forever. Yeah, I was expecting to have several projects going by now that are still nowhere near. It's really frustrating. Yeah, it's weird, but it's a
bit worrying. Looking at the news, they're saying about the shortage of building materials and the prices going through the roof.
Yeah, exactly.
Just as we're about to embark on a big project, that's not good.
Yeah, one of the things that we're looking at the moment is materials resilience for the future. So we're kind of specifically we're lucky because a lot of the materials that we use in terms of, you know, the more natural materials like earth and straw and roundwood timber, they're less vulnerable to the supply chain problems because they're not heavily processed, you know, and they're kind of locally available often. So we are, you know, a bit better, but at the same time, natural materials are more vulnerable to climate change related things. So for instance, the straw harvest 2 years in a row has been terrible. So straw is 3 or 4 times the price it was 2 years ago, and it's very difficult to get hold of. So yeah, we're planning ahead to commission farmers this year for next year, so that we know that we've got stuff. But yeah, until some of that logistical kind of chain is in place, it is very worrying, especially for kind of the kind of dimensioned timber, especially. I think that's the main worry, is either prices on that being prohibitive or there just not being enough of it going around. I'm not really worried about the cement or the gypsum or plasterboard or anything like that. We don't use it, so
Yeah.
yeah. I mean, your rammed
Yeah,
earth should be all right.
they're having problems in Scandinavia. They had a warmer winter or something. There's caused problems, and yeah, problems all round really. With all made all the worse for the pandemic and factories not being open and stuff.
Well, this is it. We've got like a triple whammy of pandemic, Brexit, and climate change is all starting to kind of knock together at the same time. So, okay, we kind of, you know, we kind of knew to a certain extent that some of these things would need looking at. I wasn't really expecting to have to start putting these measures into place now, but you know, I think what we need to do is, for us certainly, is just to have lots of different materials choices that we can, you know, grow side by side. So some like hemp as well as straw, maybe some miscanthus as well. And if we can get, because they'll be differently vulnerable at different times of the year. And hopefully if we plant 3 crops, we'll get one we can use. Do it that way.
So yeah, it could definitely influence design really. If you know, as you say, the cut and plain timber, for example, if that's doubled in price and is quite hard to get hold of, then you know, you have to think, you know, what else can I use and so on.
Yeah, absolutely. I mean, yeah, I'm not really sure what the most of the shortages are. I know that some of the more heavily processed materials like plaster and gypsum and plasterboard is because the factories were shut. So, and because of the just-in-time supply chain, it takes a long time to catch that stock level back up again. And that's what we're seeing now, is it could take up to 18 months for it to cycle back through again. But for the kind of the logging and the timber stuff, I kind of feel like that's an artificially inflated market, because like why is it suddenly slowed down? Because they should have been able to continue working through that period, because it's all isolated. And yeah, I don't know.
Yeah, you don't always know the effects, do you?
No,
that's the end of it. No.
Yeah, but
anyway, yeah, I don't have any pressing stuff really, but say trying to get more detail into the design, and we have been looking at following our well-being report, which sent you, and talking about really not using things like polystyrene and stuff. Looking at alternatives for the insulation, and unfortunately polystyrene and EPS and so on are really good materials. So if you go down to say cellulose, which obviously is a good material to use, it's
double it.
It's only half as good.
No, basically the good rule of thumb with the friendly insulations is you need double the capacity to get the same U value. So yeah, I mean, you know, when you're designing from new, that's less of an issue because you don't necessarily have the space constraints. Obviously that does have an impact on you, because you kind of do have to still fit within a site, you know. Yeah, are you thinking maybe to kind of keep the rammed earth as an inner leaf and maybe less massive, and then do like a timber frame cavity, or
we've got 300 millimeters inner thickness, which is basically the supporting structure. supports the roof and so on. So I don't think we can reduce that.
Yeah.
The review with the architects, what came out was they put forward using rammed earth on the outside totally, or as much as we can, to get this sort of simple monolithic sort of aesthetic that then we use the planting against that to get that sort of contrast, and that would be quite powerful architecturally.
Yeah, definitely.
But the thing is, we've got to put our plans through planning with EPS and 200 mil thickness of insulation. We can't just bump it up to 400 mil without probably a bit of a battle with planning to increase the footprint.
Of the building.
Yeah.
I don't know. They might. It's not that big an amendment to increase the footprint by 400 mil, because they don't care what the insulation is. That's a building regs issue. The planning is to do with the actual, physically on site, the presence of the building. So a 400 mil increase to footprint, if you don't want to alter the internal usable floor area, that should be able to get through on a material amendment rather than having to reapply and all that kind of thing. Especially if you show your workings and say, well, this is why we've done it, because it's not going to massively affect the site, is it? It's going to.
Well, no. I mean, it was just a bit of a struggle to get this thing through the first place. I don't want to poke the bear. But I suppose I'm not used to dealing with them. I don't know what they think is, important or not.
Yeah.
But the basically before we had a total wall U value. I think it was about 0.1 or 0.11.
Yeah.
And now it's gone up to 0.18. But even 0.18 is a good U value. It's I think it's the latest building regulations recommendations or something.
So for the walls it's still 0.3, which is atrocious. So 0.18 would be great.
Right. So I suppose a question is, should I just live with that? It's still good. It's not like totally, out there amazing, but it's still very good.
It is, yeah. It is
that's in combination with the thermal mass we have, the insulated thermal mass of the 300 mil thick walls. Are we going to really notice a difference?
Yeah.
We just
exactly. And it's different again for
on that.
Yeah,
it's difficult for me to make a judgment when I don't know.
Yeah, I mean, it's obviously great to kind of be aiming even lower, but the behavior of the occupants has a big something to say about this as well, because you kind of you could spend a lot of time really insulating a building, but then if the people in it want to leave the doors open because in the winter and put the heating up because they want to have a party outside on the thing, or they're having a barbecue because it's sheltered, or whatever it is they're doing, they might not be using the building in a way that makes the insulation relevant. I think what you need to do is design it for that kind of medium level of occupation, and kind of hope for that kind of responsible usage. And obviously you're going to be, hoping to educate people as they're coming through it. But it might not be as pressing, I think, is what I'm trying to say, to get the ultimate level of insulation, just because of that erratic usage of the building itself. So what would that be
because
using?
we're
If you stayed with the
holding it,
200?
you can't tell how it's going to be used entirely. We expect it to be quite open during the summer, but in the winter, it's difficult to predict what different people will do.
Yeah, it is difficult. Yeah, I mean, this is it. I mean, there's no most of the natural insulations, the nice ones, are all around the same U value. They're all between kind of 0.35 and 0.4. So yeah, you're going to have the same issue whatever you do with it.
Yeah, I think cellulose is probably as good as any other natural material,
Yeah.
really.
Yeah, it's good because it's recycled as well, so it's really good.
Yeah.
Yeah.
So
Yeah.
I'm looking at foamed glass under the slab, and
Yeah.
then cellulose in the walls, and possibly foamed glass bubbles on the roof. You can apply. I think you can either use them loose, or you can apply a binder, so you get more of a almost like a walk-on surface.
Yeah, it's more like it's almost like a highly insulated slab sort of finish.
Yeah.
Yeah. But
So
either way,
that might work quite well with the. Then we can obviously use a little bit of minimize the timber framing on top of that.
Yeah.
If that's helping to support the solar panels. So does that all sound okay?
Yeah, definitely. I mean, the foam glass is relatively light. So is this still? Have we still got the kind of the lovely Catalan vaulted ceiling inside?
Yeah.
And then you're going over the top of that.
Yeah, I mean it works quite well really, because that foam glass bubbles you can just pour it in, and obviously just level it off with the binder, and you get left with a a flat surface. Then you can just board out, put the outer.
I think you're going to need some structure in there, some rails to carry the boarding to carry the roof deck. So you are going to need some kind of tied in like rafter structure in there.
Can it be like a hybrid thing where the foam glass is part supporting?
Yeah, I'd have thought so. Yeah, you just need.
It's not going to move, is it? The foam glass one with the binder. It's. I mean, I've seen videos where they use it as on an upper floor. They just. I'm pretty sure they don't put a framework on it. I think they.
No, it's for the roof. You've got this wind uplift. That's the issue. And I know that you've got a big perimeter, but you've got the solar panels, and you'd have to protect against, because they're going to be fixed. The solar panels will be potentially. I suppose if you've got a ballasted system, I mean, you might be able to just do a ballasted system rather than a. So with a flat roof system, you've generally got two options. You've got or three options. You've got mechanically fixed, so it's a membrane that is stretched with metal bars around the perimeter, screwed down into the deck, and that holds it down. It's kind of tight with a tape welded over the top. Or you have a fully adhered system where the whole of the membrane is glued down onto the deck as it goes. Or you have a ballasted system, which is just you put your membrane down and then you put heavy stuff on top of it to stop it from blowing away. Now
okay, well, I was looking at the middle one really. So it's all bonded down.
Yeah.
I mean, we could put some ties up from the walls, the internal walls, and you've got to obviously watch thermal bridging, but over that distance, I'm sure we can.
Yeah, it's just whether you are putting the solar panels are attached to the roof structure or whether they're ballasted. So if the solar panels are attached to the roof structure, then the roof structure needs to be engineered to cope with the strong wind events that might hit it, because they can act as like a suction uplift can occur at the back of the panels when you get a strong crosswind. Which can just pull the roof off. So you have to deal with that.
If we've got the Catalan vaults, which are solid. They're kind of like all mortared in, and it's quite a high thermal mass. And then we'll have the beads on top of that, and then
it'd almost be like a suspended floor. I think you'd just kind of like have hangers around the edge that you'd hang small rafters off, and then put your deck on top of that, and they could be sat in amongst the foam glass as well, or on top of it.
Yeah, I'd have to look at the compressive strength of the foam glass with the binder, because the video I saw, they just laid down big floor areas of it, and then they just laid on, I can't remember what the materials were, there was 2 or 3 layers of boarding and whatever, and that was it.
Yeah,
there wasn't any structure.
But that's for a floor rather than a roof.
Yeah,
yeah, I think that's the difference.
If we put some sort of ties or thin struts up from the walls underneath, so that kind of like gives it point.
Yeah.
Ties it at a point, different.
I think
points.
As long as it's tied at the edges, so you're going to have to put the boards will have to be on some kind of rafter support thing, and those rafters will have to be tied to the perimeter. But it doesn't need to be massive load-bearing ones. It's literally just to tie it together and create a nice structure.
Yeah. So the foam glass with the binding will do most of the support.
Yeah.
As such.
Yeah, it's literally just a way of connecting the boards.
Any rafters, it just ties it all together.
Yeah, exactly.
So we put a load of 18mm boards down or whatever.
Yeah.
And the rafters just tie it all together.
Yeah, it's just
we fix the
exactly. So you'd have a rafter at each of the board joints so that it ties all of them together, then you'd have those rafters connected to the perimeter, and then you'd probably put a ballasted system on for your solar panels anyway, so there's some more weight on top of it as well, and that'd be fine. I mean, it's we've pretty much fill our roof with the solar panels. There's not much scope for wind getting underneath them. No, exactly. But it's just whatever the engineering says. I mean, do you know what wind zone you're in? Because I know that in East Anglia it starts to get a bit that you're in a kind of higher zone. And I'm not sure quite how inland you are, whether you're in.
It can get a bit breezy because it's sort of coming off the fields.
Yeah. There's a wind map of the UK that gets zoned almost like contours as you get inland.
Yeah.
And depending on that, you have different engineering requirements. But it's an easy calculation. So. Yeah.
Okay, we can have a look at that.
But in principle, that's
so we're planning to harvest heat from underneath the solar panels. So we'll take steps to try and minimise wind getting underneath them anyway.
Yeah.
Brilliant.
So is that what you're going to do? You're going to use the low-grade heat capture from behind the PV?
Yeah, well, it's you get the double benefit because it's beneficial to cool the PV anyway.
Yeah.
And we can harvest probably as much energy, heat energy, as we get in solar energy. If we do it right. So
brilliant.
And we can, we're planning to store that energy as thermal energy. So
yeah.
So yeah, I'm quite pleased with the way our roof layout has developed, really.
Yeah, the new drawing looks really good.
So yeah. Just going back to the walls. So at the moment we've got 300mm inside, 200mm of insulation, and then 150mm outside.
Yeah.
In rammed earth. So the inside is 2.65 meters high, and the outside rammed earth is 3.65 meters high.
Okay.
So I was just wondering about that height, 3.6 meters in 6 inches thick, 150mm. Are there any issues with that? Is that going to be?
I think we're going to need to have.
It's not load bearing at all. The outside, really, it's just got to, not fall over.
We're going to need ties. It'll need thermally broken ties because it's essentially acting like a cavity wall. So it's going to need to be constructed in a similar way. There are some really great ties called Teflon ties, which are made out of basalt. And they are not thermally conductive.
Okay. Well, they're mega expensive.
Yep. They're a couple of quid each, but they're big. So we use so it's Teflon Ties, basalt cavity ties, Twist Fix sell them. How many of those is in a box? So yeah, you can get 300 mil ones, which are obviously pretty massive compared to a normal cavity, which might just do, but you can get slightly more, or we might be able to work out a way
longer
to
than that, really.
fabricate our own.
Probably want at least 400, to be honest.
Yeah, I think they might do them. But yeah, there'll be a way of doing it.
So we just tie it to the inside wall.
Yeah, as you're building it, especially if you're using a lovely loose fill insulation that can settle around it easily enough.
Yeah. Talking of which, how big an issue is long-term settlement of the cellulose?
I don't think it is because they blow it in under a particular pressure that stops that from being a problem. It's obviously a general concern in the industry that you're going to have a lovely, well insulated passive house, and then 5 years later, the top 3 inches of 150 mil isn't insulated. That's no good. So they are very keen to say that it is consistent. Like once it's in, that's how it's going to behave. I think it's warranted to that.
Oh, okay. It would still be blown in. I was thinking we would tip it in from the top before we put in the.
I think you blow it in to deal with that, because I think if you tip it in, then there will be a problem of settlement.
Right. Okay.
I'm not sure, but warm cell will be able to advise.
Yeah, I mean, I don't know what the relative cost is. We could use the foam glass in the walls as well, presumably, but that doesn't seem to be usual. I don't know if it's because it's more expensive or why.
It's definitely going to be a lot more expensive. It's a good one because it's not vulnerable to moisture ingress at any point. It's a much more inert material, so longevity wise it's much better. We are going to use it with rammed earth in another project that I'm working on at the moment, where we've got it it's kind of earth sheltered almost. It's backing into a quarry, and the back wall of the downstairs is a quarry face, and we're going to do a rammed earth wall creating a cavity, and then we're going to fill that cavity with foam glass. And then any kind of moisture that comes in through the quarry face can just go down into a French drain at the bottom and away. And the wall will help regulate any kind of humidity, and the foam glass will be immune to any water that kind of does penetrate. So it isn't a standard detail. It potentially is going to become more of a standard detail because it works. But yeah, compared to cellulose, it's going to be significantly more expensive.
Right. And you pick that because of the self-draining aspect of it?
Yeah, for that specific reason, because we knew that one half of the cavity was 100% going to let some water in at some point. You shouldn't have that problem with your one. Obviously, you're going to have a very lovely roof over the top of this cavity that's going to stop anything getting into it. It obviously is vulnerable should there be a problem in the future, but yeah, I mean, there's other things as well. There's Perlite could be another option, which is mostly used in a similar way to foam glass as a subfloor insulation, like underneath a slab, because it's also compressive. It's also free draining inert mineral, so it's an expanded mineral, and that can be quite good, and that can be quite cost effective. We've used that in a roof before.
Okay,
that was quite good.
Is that similar performance to a foam glass?
I'm just having a look now. So they use it quite a lot as a for like pizza ovens and things like that. Just seeing if I've got an R value for it. So yeah, vermiculite or perlite is the one. Let's see if I've got an R value. It's got an R of 2.7, which is pretty good.
How does the cost compare? Do you know?
No, it's not used. There we go. What's this one? So I think they use it a little bit more in. Here we go. So 200 mil gives you a U value of 0.14. Which is pretty good. Getting it is another question.
Is that one of these sort of byproduct materials, is it? Or
it's used a lot in gardening. They use it because what you can do is you can mix it in with soil to create a looser, less compacted, more aerated soil, and that is also got a mild insulative capacity to it. So it's really good for like if you've got heavy clay soil, for breaking it up and doing that with it.
Oh, okay.
It is, where is it from? It's a mineral, ultra low density mineral, which is then expanded. So yeah, I'm not sure. Like I said, it's mostly used in agriculture for sorting the soil out, but it's the same thing. So you can, as long as you get it signed off by building regs, which we've managed in the past, they should let you use it, and then you can just get it in a bulk bag and pour it in.
Okay.
Worth looking at. So perlite or vermiculite.
Is that for you talking about walls or the roof?
For the walls, but yeah, you could use it for the roof as well.
Okay.
Worth investigating.
Yeah, definitely. We'll look at anything that performs and saves us
It's very
money.
cheap. That was very cheap. That was one of the reasons we used it.
Oh, right.
So it's so you can get it for doing like loose fill around flues, like for wood burners, because it's a non.
Yeah, I know vermiculite is used in to make fire bricks. I think, isn't
exactly.
It?
So what's this 100-litre bag here? Yeah, I think it depends where you get it from. If you get the agricultural stuff, it's pretty cheap. If you buy it as the fire stuff, they put a premium on it because of the burner market is, they see you coming.
That's quite interesting, actually. It's probably worth looking at more things that from the agricultural industry.
Yeah, they often have some interesting
savings there of different materials.
Yeah. So I'll send you
they
this.
Use so much, don't they?
Let me give you this link in the chat. So I've just sent you a link to in the chat there. I've just sent you a link to the Perlite loose fill masonry insulation sheet. So this is from America because they use it quite a lot over there. It's like a known quantity for them. So that's where this data sheet came from. But it's essentially the same. The stuff that you see them pouring into the cavities there is the same stuff that you get from an agricultural supplier in a bulk bag, which I think if you buy it from them is going to be cheap. So I don't know, see if I can get a price. £100 for a bulk bag.
For £100.
Which is that's 0.85 cubes by volume.
0.85 cubic meters.
Yeah, 0.85 cubic meters.
For £100. All right. Okay.
About that.
I'll work it out.
So that's going to give you
that's 850 litres for 100 quid. So that's it's about 12p or something a litre, isn't it?
yeah.
So that's how I get a relative thing. I would polystyrene is 6p a litre. That's the cheapest I've found of anything. This would be about 12p a litre.
I think we might need to check that because there's
yeah.
it's gardening land, and I'm not familiar. We got it in 100-litre bags, and we used it in the bags. We tiled the roof with the bags, double layer tessellated,
okay.
And then put our membrane over the top of that. And it worked really well. It gave us a really good U value because they were 100 mil deep, basically, so it worked really well. If I was doing it again, I'd probably do it loose as a cavity fill rather than that way.
Yeah, you probably get less air gaps like that.
Yeah, exactly. Yeah. This one I had mild condensation worries over it, but because of the inconsistency with the air gaps. But doing it as a loose cavity fill, it's you'll do away with all of that.
Right. And what's the approach with building control then over this? It's a material that's.
You just need to give them a data sheet. Usually, we just need to give them some kind of sign off saying this is what the U value is of this material, and they'll say yep. That's what they did on the last one. So this was in Scotland. It was a building warrant application, and we just gave them the documentation that we found, including that handout that I've just sent you. And said, look, this is the R value of it. You can find the R value. This is the depth that we've got it at. Therefore, in the build up, it's going to perform as the U value of this. And they were fine. They didn't even come back and question it. I think maybe because they already understood that it's used quite often in chimneys, etc. So they're aware that it has an insulative value. So as long as you can prove one that it has that value and then demonstrate how much of it that you're using, therefore the U value is X, then it's it's fine. We didn't run into a problem with it. So
all right. Okay. Another sort of question was tying timber structures or whatever to the rammed earth. I think one of a concern I have is, again, because we don't know who will be using our holiday lodges. If you've got a truculent teenager or something slamming doors all over the place, if you tie a door sort of pretty directly to rammed earth, you're going to, over time deteriorate the rammed earth. Or should we sort of have all the doors and such on like timber frames that are joined with rammed earth to give it a bit more resilience?
You've got two options. There's the very traditional way. So if you look at old buildings, the sort of Victorian terrace buildings, like the one I'm sitting in right now, the way they fixed everything was when they built their masonry walls, they set timbers into the wall as they were building it, so that when it came time to put the frame in, they had something to screw into, to attach or nail into, to attach, which was built into the wall.
Okay, yeah.
That's how all skirting boards are attached, all of the windows, all of the doors. If you pull out an old door frame in any of these old buildings, you'll see kind of every 300 or 400 mil, you'll see a nice chunk of wood that's either been hammered into the masonry or was built in as you went along. And the more upscale ones have better and more well fixed bits of timber. And then with enough fixings, they've lasted 100 odd years without it being a problem. And
right, that's interesting then, because I was worried about fixing the entire frame sort of directly to the rammed earth in case of shrinkage problems, or so either shrinkage on the rammed earth or on the wood causing cracking. But if it's just smaller lumps of wood that are embedded in, and then you fix the frame on afterwards, that sounds quite a good.
So you basically, what you do is you'd make something that looks a little bit like a roll plug but big and out of wood. So you can use like one of the ways that we do it when we're doing cob or straw is that you get like a hazel stake that's about 50 mil, and then you use a hatchet to chop down into it so it feathers out, so that when it goes in and then pulls back, it kind of splays out against the wall. So you can do something really low tech like that, or you could machine with a bit of 4x2 or something, you know, notches, so that when it's built into the wall, it's not just one thing that could pull out of the socket. It's mechanically fixed into the substrate when you build it in, and you'd build that in as you're going. So as you're filling, you'd put a piece of wood in and then fill the rammed earth.
Yeah, I think I like the idea of that really, because things like putting in anything that can induce like an expanding force in the wall, I'm a bit wary of, really. It wants to be like a mechanical locking type thing, which we can put in as we build, I think.
Yeah,
that's
definitely
a really good way of doing it.
You can space them nicely enough so that you have enough fixing. So if you only put top, middle and bottom, then you're obviously going to have quite a lot of flexing and shear problems with any tensions and stresses that are put on that door. But if you put one in the middle of that as well, suddenly that's exponentially better. So if you had 5 points of fixing on either side and a couple in the top, it's going to be great. It'll be really, really solid.
Okay.
Yeah. The other option, as you say, is to build like a stud frame into it, but you do have more of a shrinkage issue because your surface area is vastly bigger.
Yeah, that's exactly the sort of thoughts I was going through my mind about, you know, I'm just, you know, my belief is if you get the fundamentals right, then you reduce your problems manyfold.
Yeah, definitely. I mean, it's very unlikely to happen with the shrinkage because the moisture content of the rammed earth is very low to start with. So you don't get a lot of movement, but it is more of a risk than the other way.
Yes, yeah. And obviously timber, it can, unless it's well seasoned, it can
you've got the erraticness of the timber to deal with as well. Yeah.
You know, I was talking the idea of putting some oak posts and beams in, and they can move a fair bit really as they dry out.
Yeah.
Okay. That's that really. So I'll send you a section through as we've got it at the moment. So I've put the outer what do you call it, the plinth. I've put that directly down. I've sort of like reversed how it's quite often done. I think I've put the exterior plinth going all the way down to the crushed concrete base, and then the internal plinth is sort of above that, and that's got the insulation underneath it. So basically what I was trying to get was the internal floor and walls completely enveloped with the insulation. You know, and with no sort of particularly thin bits of insulation or anything. And I think I've achieved what I wanted to. Yeah,
so you've got the kind of the buff color. Let me just share my screen so that I can see what we're talking about. Which one is it? So we're looking at this kind of, but this darker buff color at the bottom, like these bits. So this bit's
that's the concrete, the
eco concrete, and then the lighter color is the full insulation wrap all the way around.
Yeah.
Absolutely.
Yeah. So yeah, I'm sort of fairly happy with that. I was looking at trying to do a flint plinth, but on the
Mhm.
outside. But the architect was quite keen on using like an eco concrete and getting a much more sort of monolithic look.
All right, okay, so it's like a continuation of the rammed earth in a way, rather
Yeah,
than
so I thought if we can colour the concrete to a similar sort of buff colour
yeah,
as the rammed earth, not particularly to try and fool anyone or anything, but just as a
yeah, just to tie it
aesthetically, it's
together,
a
the
similar
aesthetic.
colour.
Yeah,
And so you'll get this sort of continuous wall up with a really neat sort of double chamfered joint line
yeah.
between the rammed earth and the concrete. The only thing I did wonder about was any water running down the outside wall. Would it wick into the kind of like double chamfer?
Yeah, I mean, ideally you'd
joint?
want a drip edge
Yeah, that's what I was
between
wondering.
the
But
two. So you'd have the plinth wall, and then you have an overhang
yeah,
of it of the.
that's not the aesthetic I was I
Mm.
was going for, but that did,
Is this
I
mostly
did
to the
wonder about
front
that.
though, which is less exposed, or is it all the whole perimeter?
On the front and where we've got the sort of patio surface, I was going to treat that the same way as I'm treating the inside, and that's have the plinth just 2 inches higher,
Right.
like a bit like a skirting board, really. Again, in the sort of buff colour.
Yeah.
And the two reasons for that are in case there's any surface water, you don't want it to kind of wick up the wall.
No.
And also just wear and tear, really. Any vacuuming or anything else, you don't want it to be knocking dents out of the rammed earth. So
No, absolutely. No, that makes a lot of sense to have at least kind of 50
trying to, it would be nice to have the rammed earth go right down to the floor, but we've got to be practical.
Yeah.
And
yeah, no, I agree. I think you need something really resilient at that point of the floor. Outside, as long as it's under cover, protected, I think that would be okay. Anywhere that it's not, you really need kind of as much as possible for the kind of the splashback, because it can make a really big difference.
Yeah, on the outside, we're about 300 mil above ground.
Yeah, that's fine.
But as we were just talking about, I'm a bit worried about this water wicking down and into the joint, unless the trouble is like a little ledge, sort of a drip edge, would spoil the aesthetic quite a bit.
Yeah.
I wondered about putting running a sealant in that joint to stop it wicking into the joint.
Yeah.
I
mean,
do you think that would be effective?
Probably not. Generally speaking, I'd say that we're choosing the materials because we know that they can behave better. They're more dynamic as a material, so that the rammed earth can get damp and then expel it. It's not like a regular cavity wall where once water gets in, it's a terrible problem. The reason it's a problem is because it can't get out again. But if we've got a free draining foundation, which we have got, so if you're talking about a large amount of water, it's going to go in and down. So in your kind of that bottom part of the wall, I'd say that you definitely continue to have that free draining element. So maybe you do foam glass up to 400 mil, and then you put cellulose or whatever else on top of that. And then anything that could get into that crack can just get out straight away, either by percolating out and away, or by just natural positive pressure from inside the building pushing it out. As the humidity regulates externally, the rammed earth will do that. It will just push it out. So I don't think it's a problem. The problem would be is if you had an exposed area that was being battered by weather all of the time, so that it's a problem over time, and that's much more of an erosion problem than it is like the water getting in problem.
Yeah, I mean, you would potentially get some of that for an amount of time because you could quite easily get driving rain coming off the fields onto the north wall.
It'd be more if it was like a consistent, like when you see a leaky gutter and you see a problem patch or a damp patch on a wall. It's when you get something like that that's leaking, or there's a rivulet of water that's always tracking in the same place. That's going to cause a problem over time. But if it's just normal weather beating against it in a lovely inconsistent way, it should be fine. As I said before, I think if you think it's going to be really battered, then you should probably put some rain cladding on that aspect. But that could almost be an afterthought as you kind of see how it's weathering.
Yeah, I mean, we can apply surface sealant to it, can't we? In addition,
I wouldn't. No, I mean, if it's the rammed earth, it's either being stabilized, in which case then it's fine, or it's not. But you don't want to put any additives or anything onto it because it will stop it from performing. It's what you kind of come down to fundamentally. If you think you might need to put a sealant in, then it might not be the right choice of material for that location. That's kind of what.
Well, I mean, we're looking at stabilized rammed earth on the exterior wall.
Yeah, should be fine.
I suppose if it does deteriorate, you can always lime render it.
Yeah, exactly. You could lime render it, or you could just lime wash it. There are various different options that you can do that don't harm the performance of it. I think with it being lime stabilized, it should be fine. Yeah,
we haven't got any overhang. I've put a like a concrete ring beam at the top.
Yeah.
But there's no actual overhang. So we've just got to rely on the stabilized rammed earth to be resilient enough to the weather.
Yeah. Is there no wiggle room on that, or is that part of the kind of the clean lines facade?
Yeah, that's part of it really.
Okay.
But I mean,
that goes straight up. So your rammed earth goes straight up, and then you've got like a parapet.
Yeah.
Yeah. Can you have a bit of a drip edge on top on the parapet on what the capping is?
Yeah, possibly. I mean, we've got the just a concrete ring beam right around the top.
Yeah.
Whether we could put like a drip edge on that, but then you're only talking about 100 mil depth of that ring beam. So how much water is going to drip off that? It's not like it's a.
You'd be surprised.
Or wall's worth.
No, you'd be surprised because it's going to be. So there's some. Let me just try and find a detail for you.
I mean, I'll get the drip edge at the bottom would be quite effective because you've got the water running down 3 meters of wall, but at the top, it's actually not really running off anything.
You'd be really surprised how much will come off a parapet, and it will cause staining and damp all the way along the top in really weird, unequal amounts. It's daft just how much kind of will hit that top bit, even though it's only a narrow strip. If it can just run off down the side, then it can cause problems. There's a particular detail. It's called a water check, which is what you use on perimeter roofs. Can you still see this screen that I'm sharing?
Yeah.
So if you see this top image here,
okay, yeah.
So this is the inside of your parapet here, and this is the outside of your wall. So that would be your rammed earth. This would be your concrete cap, and then you bring your membrane up the wall on the inside to the edge, and then you put this trim on the edge there, which creates this drip edge. So you're talking about like a 20 mil, 30 mil overhang, but that makes all the difference. It would like completely alleviate any staining or damage to the top of that wall.
Okay, well, the existing wall does actually have a trim around the top edge.
Right. Okay. Well, it's probably that's doing the same. That would be the drip edge then. That trim.
Yeah.
That would be fine. And they come. Have you thought of a particular product for?
Well, the original architect, he was quite keen on polished stainless steel as a just a say a 4-inch deep trim right around the top. He thought that would be very striking.
Yeah. That'd be great. Yeah, well, there's various different places. In my roofing days, I worked with some products from a company called ICB, who use Alwitra, and they do a lot of their own fabrication work. So you can kind of come to them and say, I need a capping piece of these dimensions, and they'll make it so that it is compatible with whatever membrane system that you use. But there's loads of options out there. I mean, hopefully there'll be a nice steel fabricator in Norwich who'd be able to take that on.
Yeah, it's just quite long lengths of
yeah,
probably about 10 meters long. Preferably be that in the joints.
yeah, it's possible they can roll it
if,
into a one. You're still going to have corner pieces and different bits and bobs.
Yeah, I suppose there's alternatives, perhaps like zinc.
Yeah, there's all teams. Copper as well can be amazing.
Oh, copper might be quite nice.
Yeah, well, you can, because you've got two options with the copper. Is you can either have it coated so that it stays burnished and beautiful, or you can just leave it and then it oxidizes and gets the verdigris and it weathers in a similar way to the timber or the rammed earth will do, and it can look really quite amazing over time.
Actually, that's a really good idea. I like doing that.
Yeah, copper's great. I've worked with that a few times.
Because that would work well with the rammed earth as well.
Yeah, very nice to work with as well.
Okay. Right, I can't think of any more questions at the minute.
Marvelous.
Covered quite a lot there, really. Quite a good discussion.
No, they're good ones. Yeah, I'm good. I mean, I know it must feel frustrating to kind of still be in the detail at this stage, but it's really good detail.
Yeah, I mean, I tell myself that the more I do, save more money later on. If I can, because with the 3D CAD, the beauty is you can like detail right down to the last nut and bolt if you want.
Yeah.
So it's a lot quicker and cheaper to get that detail in now than to try and work it out on the job.
No, it's going to make everything so much easier. Yeah.
The trouble is, it's getting to summer, and I want to get outside and get on with stuff. And
I know.
I'm still on.
Yeah, me too.
Back on the computer.
Well, it looks like it's really nearly there, though.
Yeah. It's. I do find it's as we put more detail in, then you find more, potential problems, and you have to like rejig the design a bit. Yeah. But as I say, it's better to do that now than later.
It's a lot cheaper to do it now than later. Yeah.
Yeah, exactly.
Yeah.
So just trying to power on with it really.
Great. Good. Well, do carry on sending me stuff. I'm really loving the evolution. And yeah, like I said, I think we're pretty close.
Good. Okay. Yeah,
Great.
I'll send you stuff as it happens, and
nice one.
We'll talk again soon then.
Great. All right then. Well, thank you very much.
All right.
Nice
Thanks
one.
a lot.
Thank you, and thanks for all. Right. Bye.
Bye.